We now transition into performing hypothesis tests involving the population mean. This will correspond to assignment 25 and 26. Now that assignment will have 6 questions. They're 4 points apiece because there's multiple parts. We are somewhat making the assumption that you have an understanding of the general techniques we do to perform a hypothesis test. This will be very similar to assignment 24. And so again, I would suggest that you familiarize yourself with the notes before watching these examples. So we will start with example number 1. And we have the steps up here to perform this test as we did on assignment 24. So again, I ask that you follow this same process, and you'll see this on the assignment as well. So Consumer Reports says that the average life expectancy for all new vehicles is approximately 150,000 miles. So the point there would be that we're performing a test involving the mean of a population. They're making a claim about the average number of miles you can get on all new cars, and that would be considered a population parameter. So I want to remind you then that we would be doing a test involving the mean of a population, the average mileage for all new cars. All right, so that leads us to our null and our alternative hypotheses. Sorry, having a little trouble getting the tongue going today here. So I want to remind you, and these would be the exact same steps that we talked about on assignment 24. A null hypothesis involves equality. And since they're talking about the mean of a population, that null hypothesis would be that mu, the mean of a population, is equal to, and if we go back to the question in that first sentence, Consumer Reports says that the average life expectancy of all new vehicles, the mean of a population, equals 150,000 miles. So that would be a null hypothesis type of statement. And I would suggest to you that that would be what Consumer Reports is claiming. They're making a claim about the mean of a population and the fact that it equals a specific number. So as I suggested on assignment 24, let's write down who made which claim. Again, Consumer Reports is making a claim of the mean of a population being equal to a specific number, and therefore their claim would be considered the null hypothesis. All right, now, as we mentioned on assignment 24, and again, these notes are identical to the ones on assignment 24, an alternative hypothesis, HA, would be either a less than, a greater than, or a not equal to type of statement. So we need to continue reading the question to see what the alternative would be in terms of mu, all right? And so, again, we go back and read the question, and I recommend you have these examples in front of you as we do these together. But right here, it says that a certain automaker claims that the average lifetime of its particular vehicle, the Pi 314, I wonder who made that up, is more than 150,000 miles. So the auto manufacturer says our cars last more than 150,000 miles. So therefore the claim made by the automaker, given the fact that it involves more than, would be the alternative hypothesis. So let's label the fact that the automaker is making the alternative hypothesis claim. Our car lasts more, greater than the average car. All right, so the mean of our cars. So there's our null and alternative hypotheses. And like any skill, it just takes a while to read these and understand them. So I ask you to work these questions with me. I gave you some practice questions you could also do and look at the answers. So the next step in the process, you might recall from assignment 24, is to identify the appropriate test statistic. And in this case, it actually involves a flow chart, much like it did when we estimated the mean of a population. And so these questions on this flow chart that you have in front of you that were uploaded to you, this is a couple slides down the line here, they're the same questions that we asked when we estimated a mean. The first question being, is that standard deviation given to us in the question from a population or a sample? And I'll just remind you, a population is the more generic, larger group, and a sample would be a relatively small group. Well, here are the words standard deviation in this question. And as I suggested to you on the assignment where we did estimation, if you read that sentence containing those two words, right above it, in fact, it says all new vehicles, and it continues on standard deviation. So all new vehicles, that standard deviation mentioned in that first sentence, I'm taking as being for all new vehicles, and therefore that would be a population. So, as we did when we did the estimation assignment, we then go on and read the question to see if it tells us whether or not it's normally distributed. And I will tell you that if it does tell us that, then this will be the test statistic we will use. But we need to see if it says anything about being normally distributed first. So, much like we did on that previous assignment where we did estimation, I suggest to you that if you read through this entire question, and you can hit pause if I get going too quickly, as always, okay? But I don't think it says anything about being normally distributed anywhere in the question. And again, pull it up, look at it, read it with me. I do not see it mentioning being normally distributed. So, since it doesn't mention being normally distributed, we need to check to see if the sample size is at least 30. And if it is, if the answer to that question is yes, then this will be indeed our test statistic. So, you'll notice that they sampled 36 of these cars, and that's more than 30. So I hope you agree, that would indeed put us here as this being the appropriate test statistic. And so we'll write that down. And I want to remind you that we'll be plugging numbers into this thing a little bit later in the process. In fact, when we get to E, where we do the actual computation. And so let's just write the formula down for now, and then we'll concern ourselves with remembering what these symbols represent and so forth. Okay, so x bar minus mu over sigma over the square root of n. And that'll be our test statistic that we'll do later when we do the computation. All right, so these are the very same steps that we did on assignment 24. The only difference is that we're performing a test involving a mean instead of a percentage. All right, next idea. We identify our rejection region and form our decision rule, and this is where we need to read the question to see what level of significance they want us to use. I will again point out that if this says Z, then we know that this would be our good old friend, the standard normal, bell curve Z, bell curve 0 in the middle. And the level of significance here, I want to remind you that it's going to be considered a lower-tailed test if the alternative involves less than. It'll be an upper-tailed test if our alternative involves greater than, which, by the way, is the case here. And then much like on assignment 24, it'll be a two-tailed test if that alternative involves not equal. And I'm going to try to do a variety of examples to illustrate each of these. Well, so the level of significance mentioned in the question, they want us to use right here, 2% level of significance. So that would be an alpha value of 2%. And I want to remind you that much like assignment 24, the one prior to this, that is the percentage of the bell curve that we essentially are going to be giving to the alternative hypothesis. So again, the structure of performing this test is identical to assignment 24. Since this is greater than, that would go on the greater than side of the bell curve. And so we're going to put 2% in that upper tail there, as mentioned in the notes. If the alternative hypothesis involves greater than, then this will be an upper tail test. I'll take you back to that. Greater than, upper tailed. So look at that alternative hypothesis to figure out where to put that level of significance. That means that all the rest of this bell curve over here is being given to the, the claim made by Consumer Reports, the equal to claim. So again, the mechanics of this are identical to what they were on assignment number 24. I keep mentioning that, but it's very, very true. These notes are a copy-paste of the ones you received for assignment 24. All right, now to create our decision rule, you remember we need to figure out what this z-score would be right here. And so since that upper tail is 2%, that middle sliver would be 50% minus 2%. We've had that discussion many times. So that middle sliver, I hope you would agree, would be 48%, because again, 48% and 2% add up to that upper half of the bell curve, 50%. And then, yeah, we can go to the table. All right, we'll go to our good old friend, the z-table here. And since we know that that middle sliver is 48%, we've done this many a time, 48% in the body of that table, which you have a copy in front of you, 48%, middle sliver is closest to a z-score of 2.05. And this would be a positive number because it's on the upper half of the bell curve. So that's basically our cutoff between innocence and guilt of that null hypothesis. All right, and then that picture should hopefully help us write the rejection rule, decision rule. I'm going to leave this up here on every question. Reject the null hypothesis, HO, if Z, the z-score, that we're going to get in a minute when we go plug numbers into this. If this z-score that we get when we plug numbers into this ends up being greater than that 2.05, I can't say this enough times, the logic that we're following here is identical to assignment 24. All right, so if this z-score ends up being greater than that 2.05, we're going to reject that null hypothesis. Now, here we go. We go collect data, and we plug numbers into our test statistic. We do the compute step now. All right, so z equals. I want to remind you that x bar would be the symbol we've talked about many times for the mean of a sample. So the point is, we go sample some cars and find the average mileage of those cars. So wouldn't that be mentioned in the sentence here where it says 36 pi 314s are randomly selected and their average is 158,000 miles. That would be the mean of a sample, 158,000. Minus mu, that would be the mean that we're assuming is true for the entire population, the mu that was mentioned up here in the null hypothesis. Sigma, we've seen that before. That's the symbol for the standard deviation of a population, which would be this 25,000 up here in the first sentence. And n would be the fact that they sampled 36 cars, wouldn't it? Okay, sample size. So all those symbols we've mentioned many times. Again, continue if you see a formula like that, you get confused, just go back to this chart that we've had up here ever since the very first day of class and look for these different symbols and plug them in, all right? So, now, this is where I have to say I'm not doing this any differently than I would if you were sitting in this room with me. The compute part, I have to be a snob and say that's the order of operations here. Grab your calculator. I hope you get the same numbers that I'm getting. These are on a slide with the things that were provided to you. And so, if you want to hit pause and push buttons for a while and see if you get the same thing, that's great. But crunch, 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 and you would get the fact that this z-score turns out to be 1.92. And I will again tell you that this is also on, the slides that are given to you as well. So that was crunching these numbers out, 1.92. And then, of course, what we're beginning to talk about here is that after we compute that test statistic, which is jamming numbers in here and pushing buttons, then the very most vital step would be to make a decision and interpret. All right, so the decision is basically whether or not to reject the null hypothesis. So there's two ways you could think this through. I don't care. You look at this and say, well, is 1.92 greater than 2.05? Nope. Well, then we're not going to reject the null hypothesis. That would be one way of reasoning that out. The other would be to look at your picture over here and see where the 1.92 falls. Let me get the alpha out of the way so I can put that in there. But it wouldn't 1.92 across the bottom here where all these z-scores live. Remember, these are z-scores, and that's a z-score. Wouldn't that 1.92 be in this region that basically we were giving to the null hypothesis? So either way, you'd hopefully say, well, I'm not going to reject the null hypothesis because that landed in the null hypothesis part of the bell curve. Or you could say, that number's not bigger than 2.05. I'm not going to reject the null hypothesis. I don't care which way you reason it out. One way or another, you hopefully come to the conclusion, as you see on this slide. Maybe it's hard to see it on the screen, but you have it on the printout. Do not reject the null hypothesis. So, now the biggest thing of all is to make a conclusion. Answer the question that was presented to us. So, you look at that, you go 1.92 falls in the area that we gave to the null 1, the court case. I come back, I put a star next to the null hypothesis to help me realize that the null hypothesis is the thing that actually won the trial, so to speak. Now, when we write up our interpretation, we need to answer the question that was given to us. And I want to point out the question could have said, is the claim by Consumer Reports true? And you'd say yes, if that were the question. Or the question could say, is the claim made by the automaker true? See, so it just depends the point of view upon which the question is asked. So this is why I continually tell people to take the actual question and use it to formulate your answer. You will notice here that the question at the end, at the 2% level of significance, is there evidence to support the automaker's claim? And they were the alternative hypothesis, weren't they? That is why it's so important to label the null and the alternative as to who made which claim here. The question is from the point of view of the automaker. There is not evidence to support the automaker's claim. They lost. So label these, put the star next to the winner, and then use that to answer the question that was given to you. So, finally, interpretation. At the 2% level of significance, there is not enough evidence to support the automaker's claim. Ouch, okay? So, again, if the question had been from Consumer Reports' point of view, the answer would have been, yeah, there is evidence. So it just depends, point of view as to how the question is asked. And so, label who made which hypothesis. When you're done computing, stick a star next to the winner, and that'll help you formulate your answer. And I would again, one more time tell you that this interpretation that you see on the printout, for example, number 1, if you look at it, the wording of that answer is pretty much a copy-paste of the question. So use the question to formulate your answer. That's the best suggestion I can give for you. So that's example number 1, and I think we just need to keep practicing. All right.